Hey everyone, I'm Dr. Marie McNeely, your host for People Behind the Science. Thanks so much for joining me today for our 666th episode featuring Dr. Mita Dasog. Listeners, if you like this episode and you want to check out more stories from phenomenal people doing great science today, you can find more episodes of our show on Apple Podcasts, Google Podcasts, Spotify, or wherever else you like to get your podcast fix. And today, Mita has some fantastic stories of her own to share with us. So listeners, get ready to meet another one of our outstanding people behind the science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to People Behind the Science. Today, I am thrilled to be speaking with our guest scientist, Dr. Mita Dasog. So welcome to the show, Mita. How are you?
I'm good. Thank you. Thank you so much for having me today.
Well, we are excited to learn more about you and the wonderful work that you do. But let me first give our listeners a little bit more information about your background and how you got to your current position. So listeners, Mita is an associate professor and the Izaak Walton Killam Memorials Research Chair in the Department of Chemistry at Dalhousie University in Canada. She received her bachelor's degree in chemistry from the University of Saskatchewan and her PhD in chemistry from the University of Alberta. Next, she was selected as a Green Talents visiting scholar to work at the Technical University of Munich in Germany for about 7 months. Afterwards, Mita was awarded a Natural Sciences and Engineering Research Council of Canada postdoctoral fellowship to conduct research at Caltech. Mita has been recognized with numerous awards and honors, including the Nova Scotia Discovery Centre Emerging Professional Award and the President's Emerging Investigator Research Excellence Award. She is also an elected member of the College of the Royal Society of Canada and a member of the Global Young Academy. And Mita, today we're excited to get to know more about you as a scientist, but also more about you as a person. So can you start by telling us what you like to do when you're not doing science?
But lately, I've been listening to a lot of CoComelon because I have a little one. I haven't had time to do a lot of fun stuff. But before that, I used to like to read a lot of mystery novels, and I also like to paint and cook.
Oh, fantastic. So what do you like to cook?
I like to explore a lot of recipes. Of course, I have an Indian background, so I do make a lot of Indian food. But I've also been trying to make sort of Thai, Chinese food, and also Mexican food.
Oh, that's amazing. I know for me, I sort of oscillate between periods of frozen pizza and trying to make something more elaborate. So I'm always impressed with people who have this passion for cooking. So then you mentioned mystery novels as well, and we love talking about books on our show. Do you have any favorite books that you've read, whether they're mysteries, whether they're science related or something entirely different that you can recommend for me and our listeners?
Not a lot of science related, but I do read a lot of Janet Ivanovich and Sue Grafton, a murder mystery series. So anything by those authors, I think I've read most of them. And of course, the classic Sherlock Holmes.
Oh, that's wonderful. So what really draws you into these mystery novels?
I think it's the unknown. I really like figuring things out, probably why I chose this profession, and just figuring out the story, who did it, why it happened. I really like the unknown, and that thrill of finding the answer is really what I like about mystery novels.
Oh, that's amazing. Well, we will add these authors that you mentioned to our list on our website for our listeners to find if they're looking for a summer mystery thriller to grab their attention. So let's talk a little bit about your science next. How do you describe the work that you do in the lab to people who might not be familiar with your work specifically, or maybe your field more generally?
So my team works on nanomaterials. So nanomaterials are very, very tiny particles or materials. So our group looks at making these. So on a fundamental level, we're trying to understand how these form, what dictates their size, their shape, and how all of that affects their properties. But then we also like to use these nanomaterials for a lot of applications. And the specific applications our group is interested in has to do with a lot of challenges we're currently facing with climate change. So energy production, sustainable fuel production, desalination to help with the water crisis. So these are some of the challenges we are working on, and we are making sort of these functional materials using abundant elements that we find on this planet.
Oh, wonderful. Mita, I'm excited to dive into more detail on these projects as we go through our conversation today. And you mentioned that you have this fascination with figuring out the unknown. And I think this is something that drives a lot of scientists, but I love digging in deeper to understand what motivates and inspires scientists. So do you have a favorite quote or a saying or just something that really resonates with you and gets you excited about work?
I think my favorite quote really depends on where I am in life at the moment. And I actually really came across this really nice quote just yesterday. I don't know who the author is, but I believe the quote goes, "You don't need to be perfect to inspire others. Let people get inspired by how you deal with your imperfections." And that really resonated with me. And I think especially in the current times where everyone's really stressed out, it's very applicable. But I think also with the science, oftentimes we try to be perfect and find the perfect answer to everything. And sometimes not so perfect answer is okay as well.
Absolutely. And I think many of the scientists that I know are these very detail-oriented, perfectionist sort of people. And I think to inspire your trainees, to inspire the public, you don't always have to get everything right all the time and have every detail down to the T.
Exactly.
Well, that is a fantastic quote. Thank you for sharing it with us. And I'd love to maybe start at the beginning of your scientific journey and understand a little bit about how you first got interested in science to begin with.
I was thinking about this, and I am very lucky, actually, because my dad is a scientist and he's a professor. So growing up, even when I was as little as 4, I believe, I visited his lab. I would look at all these very colorful solutions in his lab, which I think was very fun for me. But I don't think I really understood what science was or what research was, even though I visited his research lab so many times growing up, because I always thought science was a done deal in a way. We had figured out a lot of the things. They were in the textbook. We learn about it. And all we do is essentially take those concepts and apply it in everyday life. So I think it was more around grade 8, grade 9, where a lot of things came together for me that really got me interested in science. I had a very good science teacher, which piqued my interest, especially in biology. And my dad had actually gotten this really big grant around climate change and water conservation in particular. So his project involved working with coastal communities, seeing how we can use coastal water. And his work involves a lot of field work. So when he was going to visit these coastal communities, I was very excited. It was summertime. I had school break. So I was like, oh, can I tag along and go to the beaches while you go do your work? And he said yes. I was very excited. But before we could go to the beach, I also tagged along on his field work. And I saw him interact with people, with communities, with farmers. And I think that was the first time I realized that science wasn't as static as I previously thought it was. It was more dynamic. It was evolving, and it can be tuned, and we can look into solutions that currently don't exist to solve challenges we are facing. So one project that really caught my attention was they were trying to find crops that could potentially grow in salt water, because irrigation is a big issue in India. So this happened in India, and it uses a lot of water. We grow a lot of rice. Rice uses a lot of water as well. And there isn't always a lot of water around to grow it. So they were trying to see, is there any way you can engineer the crops to have them survive in salt water? So they were studying plants that would grow in salt water. And what is it about these plants that allowed them to survive it? And could we then transfer those properties into crops? And I was blown away. That was such a fascinating thing to me. And such a fascinating concept. I saw how that could really affect people's livelihoods and how it was very current and how it would, like, there was no answer. So this was something that we had to figure out. And I got a little bit more deep understanding of why science is important and how science works and what research is. So that trip was really the turning point in a way. And I started to take more interest in my science courses in school and started attending science camps. And the next summer, I had this very cool opportunity to participate in a science summer camp where we did very high level experiments that we typically do in universities. And I think I wanted to go into biotechnology because of project I'd seen. And I was like, oh, I want to do that, like crop engineering and plant engineering. And when I went to university, I really wanted to get into a biotechnology program. And I completed my first year of university in Canada at University of Saskatchewan, which has a great biotechnology program. But that summer, I had a chance to work in actually a chemistry lab. And that was the first time I was introduced to the concept of nanomaterials. I had no idea what these were. And that, again, completely changed my direction because I really enjoyed what I did, what I learned that summer. And that's the path I've been since.
That's wonderful. And I really love that you brought up this point, Mita, about discovering that science is sort of not just about memorizing information from a textbook, that it is about solving these real world and new problems and answering new questions. Because I think that's something that a lot of young people maybe don't realize because in school, you're just kind of exposed to the textbooks only. So it's been great to hear about your journey. And you mentioned your dad perhaps as a particularly important figure in kind of shaping you as a scientist. Are there other role models or mentors who came up along the way who really had a big impact and helped you get to where you are today?
For sure. Again, I'm very lucky. I've gotten to meet and work with so many great people. And I think my role models have definitely evolved over time. When I was younger, of course, I had my dad. I have two older sisters who are engineers, who are great role models as well. I had a very good science teacher, as I mentioned. But outside of my family and my tight circle, when I was young, a lot of my scientific role models were these very big name scientists who had all these awards, accolades, of course, very successful. Not people I had met really, but, I kind of looked up to them, sort of something to aspire to be. But as I've grown and as I've spent time in academia and I know sort of what it takes, what happens, how things work, my role models have changed and evolved with that because now I look up to people, not just who are great scientists, but also are great human beings as well. Because I think that's very important and often hard to come by sometimes. People who are empathetic, people who are grounded, people who are willing to make time, who are very respectful. So a lot of people I look up to now are these types of people in my circle, like colleagues, even my students, and in Canadian community, people I come across who do great science and I meet them and I'm like, wow, you're just such an incredible person. And that's really what I want to aspire to be, not just do good science, but also be a good human being at the end of the day. And because I had a kid recently, I also look up to a lot of academic moms who are such superstars. And it really boggles my mind how they can do it all sometimes.
Oh, definitely. Well, I love how you have these kind of different role models for different aspects of your life. And I think that's something that's an important point to make too. Oftentimes I feel like students feel they have to have one mentor in graduate school, but I think you can kind of align yourself with a lot of different mentors, a lot of different role models to model these different aspects of your life, because scientists are these multifaceted people. We're not just the work we do in the lab.
Exactly. And I love that we have the opportunity to actually look up to and interact with so many people and really pick all these good qualities from each individual.
Absolutely. So I'd love to talk a little bit about then how you got to where you are today. So we talked about how it all began, but then can you tell us a little bit more about your experience getting more into the field through your PhD and through some of these postdoctoral experiences and how you ended up there at Dalhousie?
Like I said, I really wanted to get into biotechnology program. And that first summer after my university, I worked in a chemistry lab. I really enjoyed what I did. And again, I was very lucky to work with this brand new professor who was just setting up his lab. I can't even believe he gave me this opportunity because as a first year undergrad, I really didn't know what research was. I mean, I know my dad is a scientist. I had some understanding, but I hadn't really worked in a lab. So I didn't know that you're really working in unknown. You're not just working on what's already been done, but sort of trying to push that further and working on a new challenge. I didn't know much about scientific papers. And they're very dense and it's hard to read. I always tell my undergrads now is that don't get intimidated because my first research paper I read, it took me weeks to get through and really understand what they were trying to say. But I had a very patient mentor who sat with me, explained all million questions I had. And that really got me excited about chemistry and nanomaterials in general. And something I like about this field of material science is that, yes, I'm trained as a chemist, but material science is a very interdisciplinary field. There's chemistry, there's physics, and depending on the application, there can be engineering, there can be biology. So I felt like I can really do whatever I wanted and really shift focus depending on what my interest was. And during my undergraduate studies, I did explore other fields of chemistry as well, which was very good advice I received because people were like, really, now is your chance to play around, figure out what you like. So I spent time in other labs. I did some molecular work. I tried to do some organometallic chemistry, doing metal complex work. I did some catalysis. I did some phys-chem projects, trying to understand triplet annihilation. And some were successful, some not so much. Some I really liked, some not so much. Again, I had a chance to really figure out what specific subfield of chemistry or the topic I wanted to explore. And I sort of came back to material science because I found to be attracted to that field just because the variety it provided. So after my undergraduate, I went on to pursue my PhD. So I wanted to do it in material science, but not on the material I had worked previously. So as an undergrad, I worked with a lot of gold and metal nanoparticles, and I wanted to do something different. So for my PhD, I decided to go to University of Alberta, which was just a province over. And there I decided to look at quantum dots. So people probably have seen QLED TVs now. So the Q in the LEDs are actually quantum dot LEDs. So these are these luminescent materials that now have actual applications. We have products in the market based on these. And I was studying silicon-based quantum dots, which was a little bit of newer class of materials, and trying to understand where the colors, the photoluminescence was coming from and how can we tune that. It's a lot of fundamental work, but also has implication on its application as well. And that's something I've always liked, and that's something I still do in my current research, is establishing this structure-property relationship. I always like studying the fundamentals and then understanding how that impacts what we can actually do with that material. So after I did quantum dots, now, again, I wanted to shift gears and do something different again. So I had this cool opportunity when I was selected as the Green Talents Scholar for Germany. And I wanted to do something that was sustainability related. So when I went to Germany, I did an energy related project. And my dad, when he was working, climate change was really the driving factor behind the project he was working on. And that's something I was interested, that was always in the back of my mind, but I never actively pursued it. So now was my chance to sort of come back to that core problem, working on a different aspect of it. So I looked at sustainable chemical production. And when I went to Caltech, I sort of worked on very similar type of problems, again, sustainable fuel production. And after working there, I started here. I came back to Canada. And I always wanted to sort of come back to Canada. So it was great to get an academic position here at Dalhousie University. And I wanted to continue working on these sustainability challenges and find pathways to make chemicals that we use in our everyday life in a greener way, less energy intensive way. But also going back to the water challenge that really inspired me. There's not a lot of fresh water supply that we currently have, and it's a very big issue. Every year it's getting worse. So being able to come up with the desalination process that's, again, less energy intensive, that is scalable, maybe not so rich countries can adapt, is very, very important to me. And those are the challenges we are currently working on.
Definitely. Mita, I know you've got a lot of cool projects going on. We mentioned a couple of them that just have these really important applications. I guess, do you have a favorite project that you're working on right now that you want to dive into in a little bit more detail and tell us about?
Ooh, that's difficult to pick. Obviously, I'm not alone in working on any of these challenges. There are many, many talented scientists working towards the same goal as well. So I think my personal favorite project is something I didn't really intend to work on, to be honest. It's not a class of materials I was actively pursuing. It sort of just came about in our lab a few years ago, and it's not a very well-researched area. So they're called plasmonic nanomaterials. Now, plasmonic nanomaterials have existed for a very long time. So if you look at these very old European churches, the stained glasses, they actually have these metal nanoparticles in them, which gives them these very beautiful red, yellow color. And these are gold and silver nanoparticles. And that's because of their plasmonic properties, that their colors change. And since accidentally making these metal nanoparticles centuries ago, we still rely on gold and silver predominantly when it comes to plasmonic applications. We take a rapid antigen test for COVID now, and we see that red color flow by. So those are gold nanoparticles again. So they still exist, still mostly used for a lot of the plasmonic applications. And we are trying to find alternatives to gold and silver because they can be expensive. They have some other stability issues as well. And we came across these class of materials, which are ceramic plasmonic materials. And we have been exploring them. There's not a lot that's known about them. So it's scary because we're going into this unknown world, but at the same time, quite exciting, because it is unexplored territory and there's a lot to figure out. There is a lot to play around. And again, there's a lot of fundamentally unknown things about these materials that we still need to understand what they are, how they behave, what their exciting qualities might be, which can then open up a whole new door to where we can use these materials. So this class of ceramic plasmonic materials is something I've been quite excited about. We actually had some very cool results just yesterday on this project, which I can't quite get into today, but there's a lot to play around here. So I feel like a child almost working in this field.
Definitely just that thrill and that uncertainty when you're pioneering a new research area with these plasmonic nanoparticles. That is so cool. But I know not every day is full of fantastic, exciting new results. But I'd love to talk about the struggles, the challenges, and the failures, because I think in science, we don't hear about these enough, but it is a really big part of life as a scientist. So Mita, do you have an example of something that you really struggled with or a big challenge that you had to overcome and how you were able to work through it?
Like you said, I think something people might not realize is that as a scientist, you actually have more failures than success. You sort of get so used to it on a day-to-day basis because not everything works in the lab. I mean, there have been quite a few challenges and failures, but I feel the last 2 years in particular, and not just about one thing not working out, it's just a collection of things with the pandemic and just things shutting down. Still trying to keep the group motivated. All the facilities were sort of shut down. We couldn't quite do the work we wanted to do. When things fell apart, repairs were hard to come by. People couldn't travel to fix the instruments, or there's a big supply chain issue right now. So even getting small parts for things is quite challenging. So I think kind of collection of a lot of these challenges, a lot of personal challenges, really takes its toll on a day-to-day basis, and just keeping your head above the water through such a long period of time and keep things going has definitely been challenging. We are starting to come out of it a little bit, but I think a lot of people are burnt out at this point. So it's interesting to see how things will go over the next few months or the next year as the world comes back a little bit. I think we have seen a lot in the last couple of years as how people behave and people's strengths, people's weaknesses. So there's a lot we have learned about ourselves, about humanity in general, I believe. So restructuring how we work, how we incorporate everything we have experienced so far, I think is going to be interesting. And as a scientist, a part of me looks at the data that is in front of me and try to approach this analytically. And I know it's not always that straightforward because there's people involved and emotions involved, but to kind of figure things out, to come up with a sustainable way moving forward, as I know people are exhausted, is going to be something I still need to figure out. It's still a big unknown. And I know it's not a direct scientific challenge, but it's a big part of it because at the end of the day, it is people who do all this science.
Absolutely. And I think it's so important for people to remember and to realize that. And I know this pandemic has touched really absolutely everyone in different ways. And it does make you really appreciate things that you sort of used to take for granted, like just being able to put in an order for certain parts or certain equipment and supplies that you needed. And now it's become way more of an ordeal for sure. Well, we talked about the challenges, Mita, but we don't just want to focus on the negative side of things. I'd love to talk about some of your successes as well. So do you have a favorite success in science, whether it was a big win or just a small but particularly meaningful one?
There's definitely wins for sure. If you had asked me the same question a few years ago, I think I would probably talk about a paper or a grant or a project working out, which still happens. We still have those papers, grant projects. But what really makes me happy now is seeing my students succeed. And we just came out of a very packed conference season and just watching my students be so excited and do such a fantastic job to stand up there, talk about the work they're doing to the community, to explain it in a way I couldn't think of doing it when I was in their place. And just seeing these young people do so well, knowing they have had a tough couple of years as well. That was just so inspiring. And I think that was the big win as a PI to me personally, just seeing them succeed, seeing them win all these presentation awards, get all this recognition, have my colleagues come up to me and be like, hey, your student was fantastic up there. There's no bigger win than that.
That is phenomenal. I think it's inspiring and also reassuring, kind of seeing that next generation who's going to keep moving science forward.
Exactly.
Well, congratulations to you and, of course, to your students as well. Do you have a particular favorite way that you like to celebrate these kinds of successes in the lab?
My group is very supportive. They are constantly celebrating, to be honest. I have great bakers and cooks in the group, so they're always bringing in goodies as we celebrate things. There's always baked goods that the group members bake, but we also just take time, go have lunch or go out to eat or take an afternoon, do some fun activity. We have celebrations for defenses and things where we open a bottle of champagne. So there's many different types of celebrations that we have in groups, really.
Fantastic. Well, I think it is so important to recognize these achievements of your students and really exciting as well. And we talked about your life as a scientist, and I think there are a lot of people out there who may not realize all these different facets that go into a career as a scientist. You're training students, you're helping train that next generation of scientists, you're doing your research, you're often teaching, but you're also doing quite a bit of travel in a lot of cases, whether it's going to conferences, working with collaborators. This is a big part of the job as well. So, Mita, do you have a favorite place that your science has taken you?
I've gone to so many beautiful places. It is so difficult to choose one. I haven't done a lot of traveling in the last couple of years, but I think my stay in Germany was really great back when I had a chance to actually stay there and work, because I got to see a very different culture. Probably a culture that has a little bit more work-life balance. And I really learned that and I like that. I was able to take that. But visiting really any country, any different country, different culture. I've been to Japan and Portugal before the world shut down. Those were fantastic trips. Like I said, I enjoy food and just exploring culture there. And of course, scientists and science, that was amazing as well. But really, I must say, every place I've been to has something wonderful to offer, something I can learn and take with me.
Absolutely. And I like the point that you mentioned in terms of when you went to Germany, you were actually able to work there, to spend some time there, to really get to know the culture. Because I think when you're on this whirlwind 3-day, 7-day tour for a conference, you're very limited in what you can do. So having spent 7 months or so in Munich, what are some of the things that you really recommend people check out if they go there?
There is so much to do. There is a big park in the city center that's wonderful. You can walk around forever. I think they have one of those simulated surfing area, which is quite fun. It's bike friendly, so possible bike around, but there's just a lot of things to see. But my personal favorite thing was really just going on picnics at these parks. I definitely recommend that. Checking out beer gardens if you like beer. And I really like the outdoor laid back concept where you can bring your own food and sit outside and just enjoy. I think I was there during the football season as well as the World Cup was happening. So just being able to sit outside and watch these football games on big screens was a lot of fun as well.
Well, it sounds absolutely wonderful. Listeners, definitely put these things on your to-do list if you're heading to Munich anytime soon. And we talked about different aspects of your life, different aspects of your career. And I think a lot of people, when they hear about scientists, they've got this very specific image in their mind about what scientists are like and what life as a scientist is like. And I think in so many cases, this is just not true. So we love to break some of the stereotypes that people have on our show by talking about just the fun and human side of science, the quirky traditions, the great, hilarious memories you share with colleagues. So do you have an example of one of these stories, Mita, from your experiences that you can share with us today that goes against the sort of stereotypical traditional scientist that people picture?
I think one of the most fun I had was when I was a PhD student. We used to love pulling pranks on my PhD supervisor. And I led a lot of these pranks. That was one of my favorite things to do. And I think we pranked him 3 times. We pulled sort of pretty big pranks. The first time we changed his office to somebody else's office. And we were so detail oriented, like even conference badges he had in his office, we changed names on those.
That is impressive.
We printed new ones into this fake person's ID. We changed his family photos. Of course, we didn't destroy anything.
Sure.
But we completely transformed his office into somebody else's office. The other time we filled his office with balloons. And the third time, I think we put aluminum foil around every surface and everything in his office as well. So,
oh, wow. So was he surprised? Did he know exactly who did it?
I think he was surprised. And of course, he had a very good sense of humor as well. So that's always fun if your supervisor doesn't get mad at you for these things. I don't know if he was surprised that I did it, but he definitely enjoyed it. I thought it was funny at least.
I love it. And it sounds like this fun side persists in your lab today. Are there current pranksters in the group or any fun traditions that you guys have right now?
I haven't been pranked by my students, so I'm thankful, I guess. I don't think they've figured out how to prank me yet. But if they hear this podcast, I feel like that might be something in my future. We have a few fun traditions in the lab. Like I said, the group is great. They have a lot of fun. I have a student who loves photoshopping my face into things. So every once in a while in group meetings, I'll see my face somewhere where I don't expect it to be. And now they make these funny Christmas cards that are photoshopped. That has kind of become a bit of a tradition now, which I think is quite funny. But I just sometimes walk into things. There was one summer I walked into a student office. I think they were having a rap battle. So you never know what you'll encounter.
Oh, that is fantastic. And I think encouraging this creativity, this joy, this sense of fun really helps the science as well, because you're answering some really tough, really important questions in the lab. And I know oftentimes you face limitations, whether it's funding, staff, time, technology, feasibility, whatever it might be, that kind of keeps you from answering those creative dream questions that you had. But Mita, if we took away all of the barriers you normally face, is there one research question in particular that you would want to tackle most?
That's a tough one because we have so many challenges right now. But I'll go back to water. And I think if we could figure out a cheap way, a less energy intensive way to desalinate water in a scale that we could even use not just for drinking purposes, but also for irrigation purposes, and how to get these to remote communities or have a technology that just works in remote communities. I think that that's one challenge I would love to work.
Absolutely. And I think with this challenge, you hit the nail on the head there. It's not just kind of designing things that work well in the lab. You have to design solutions that are portable, that can get to these places and work in these environments.
Exactly.
Well, fantastic question. Thank you for dreaming big with us on the show today. And we've talked about a lot of different aspects of your life and your career. And I'd love to end with advice for our listeners out there who might be on their own scientific journey. So, Mita, what is the best advice that someone has ever given you?
I think the best advice is stay curious. I know it's a bit of a cliche, but I think the curiosity really is what drives science, especially on a day-to-day basis. So being curious is very important to scientific discovery, but also remember that this is a team endeavor. I know we have this tendency to highlight individuals, celebrate individuals, but really at the end of the day, science is a team effort. And I am here only because of my team. So remember that you're not alone. You can always go to people for challenges, but also know that when you do work in science, you're not going to be alone either, that you will have hopefully a supportive team.
Definitely. I think these colleagues, collaborators, trainees, they're there with you during the tough times, but also there with you to celebrate those successes as well. So important to form that network and get that team together. Now, Mita, is there any other last piece of advice or a last note of inspiration that you want to leave our listeners with at the end of our conversation today?
I hope it's not too preachy, but really as a scientist, things I've seen in the last couple of years breaks my heart a little bit. There's so much conflict in the society, the vaccination, mask mandates, and the rebellion side of humanity we've seen almost against the science, and how scientists don't know what they're doing, what they're saying, because things are evolving. And I can understand the frustration behind that. But I think going back to science literacy and making that connection between what you might have learned in the classroom, in the textbooks, and making an effort to use that to make decisions in your real life, because they do dictate everything that happens around us. Rely on those fundamentals that we have learned. So being able to make those connections, I would recommend people to not just leave that knowledge behind in the classroom, but as they go into the world as a consumer, as a citizen, as just a person, to question things and see, what do I know? What have I learned? And can I use that knowledge to make an educated decision about products, about policies and things like that? I think that's something that really needs to happen.
Absolutely. I think you don't have to be a scientist as a professional to engage in this critical thinking, to use logic, to evaluate and to make those decisions in your life. So I think that is such an important message to share with our listeners. And we talked about a lot of things today. If you've piqued the interest of our listeners out there, Mita, what is the best way for them to get in touch with you or to learn more about you and what you do?
We have a research, our group website, so you can visit dasoglab.ca. I'm also on Twitter, so you can follow our group at Dasoglab as well. And I can be reached through emails as well if you want to personally get in touch with me. And that's mita.dasog@dal.ca.
Fantastic. Well, listeners, definitely check out that website. Get in touch with Mita if you have any questions. And Mita, thank you so much for joining us on the show today.
Thank you again for having me. And thank you to everyone for listening in.
Well, it's been a pleasure to get to know you and your work better. Listeners, great to have you here with us as well. We'll see you next time on another episode of People Behind the Science.